Hi, everyone. Welcome to ProjectPro Expert Talk Series. Today, we are honored to have with us Dr. Kirk Borne. Dr. Kirk is a very popular top worldwide data science and big data influencer. Before that, Dr. Kirk has spent his time across multiple advisory boards, multiple consulting assignments, speaking assignments, including multiple TED Talks across world forums. Earlier, he was a principal data scientist and an executive advisor at the Booz Allen Hamilton Consulting Company. And then he actually graduated with a PhD in astrophysics from the famed Caltech. Astrophysicist and a data science influencer with us. Thank you so much for taking time, Dr. Kirk.
Great to be here. Thank you.
Terrific. I would love to start off by asking, you have a strong interest in areas like data democratization, storytelling, data literacy. How did you kind of hone in on those areas as your areas of interest? How did that happen?
Well, you might say it had a lot to do with my astrophysics background.
Okay.
Because as an astrophysicist, I was always working with data, analyzing data. And then I discovered this thing called machine learning about 20-something years ago. Mm-hmm. And I said, this was really an interesting way of dealing with data. And I realized there's all kinds of different applications, not just in the sciences, but outside the sciences. But if I was going to be a legitimate person working with other types of industries outside of the sciences, like marketing and government and healthcare, cybersecurity, and all kinds of different areas, I would have to be able to talk with people way outside my field, and they would have to feel comfortable talking with me from a completely different field than them. So data literacy to me was always about having a common terminology and language to people to talk about. What kind of data do you have? What kind of value do you expect to achieve from it? What kind of things can you do with it? Insights, discovery, what does that mean? So it's really all about that sort of the breaking down the language barrier, but at the same time, it's breaking down the barriers in business that keep progress from happening, and which is what data democratization is trying to accomplish, is breaking down those barriers, allowing everyone who has any access to data within the organization, if they see something in the data, they should be empowered to say something about it. So that insights discovery is a natural human thing, right? You don't need to have a certain degree, a college degree or a particular set of training to be able to see something and know that there's something interesting, some interesting pattern or correlation or something. And so it's really about helping organizations really bring the best value out of their data projects, from the frontline workers to the developers and coders who are implementing it, to the business decision makers who are figuring out how to achieve competitive advantage in their market. So all those things just sort of work together for me to have a successful data analytics enterprise. And so a lot of the consulting and strategic work that I've done is helping companies to see things that way. That's
helpful. Thanks. And, when you look at the software, the developers who are implementing these projects, right? The 70s and 80s were the age of the, probably the hardware developers, where that was the thing to do in the 70s and 80s. And then the 90s and the early 2000s and the 2010s, the software developer was the thing, which is largely the case right now. Do you think the data developer is probably the next phase of what everybody is going to become? Or do you think all the 30 million software developers out there will eventually have something to do with data one way or the other? Or do you think that's going to be largely restricted to one subset of them?
I think that's an interesting progression you described there. And I do agree with that I think the transition from hardware to software developer, like you were describing, I lived through those years, right? I was in grad school in the late 70s, did a lot of computational science. I did models of colliding galaxies. There's some images of them behind me on my Zoom call here. Yeah. And in those days, it was very difficult to really spin up the hardware to do some kind of hard computational problem. You had to allocate the disk space. You had to allocate, the printer spooler. If you actually wanted to print something, I mean, there was all kinds of crazy stuff you had to do to get the hardware to play nice with with what you wanted to do, right? And so that problem was sort of solved. It was sort of abstracted away. And then software development became really at the center of focus. People could say, I'm not going to focus now, have to worry about how do I load a spooler? How do I load a hard drive? How do I all these, how do I assign the network ports to my job? That stuff is sort of transparent. And so the software development industry just took off with all the different ways that you can implement things in business. And so then this data revolution comes, and now data is being the fuel, so to speak, that transports knowledge and insights across all the different sections of the enterprise. Yeah, software developers are still implementing those things, but I think more and more people will be able to tap into that without necessarily knowing all the intricacies of software development. Just like the modern day software developers, don't have to really think twice about how do they allocate a spool to print something on the file. I mean, you can't imagine how painful that was back in those days. I mean, if you just had the wrong comma or semicolon in the wrong place, you couldn't even print your job out. I mean, so we're really moving to that place where more abstraction leads to better productivity and new products and new innovation, because people aren't inhibited by those barriers. And so the new roles of the software developer will include data developer, as you were describing. It won't necessarily get rid of those software development roles, because I don't think it's going to go quite as far extreme as the people who spent their whole lives developing hardware systems.
Yeah.
There are companies that do that now. Individuals don't have to do that.
Understood. Okay. And you mentioned a couple of points about the abstraction of the data access, so that you don't need a software developer to be an intermediate to get that for you anymore. And that kind of leads into one of your specializations of data democratization. Do you think there are specific industries out there that are leading the progress in that area? Who are they, and what is making them kind of push the envelope on that?
Well, the good news is just about everywhere now.
Okay.
But I think, I hate to even pick one or two industries, because there's so much development in every industry, but certainly any industry that's dealing with customers in some way or another, either through customer relationship management, like marketing companies and things like this, customer call centers, but also customer product development, designing and knowing what people want.
Yeah.
Supply chain delivery. So anything that faces customers, there's all kinds of tons of data, obviously, and tons of development around that. But also, if you just start looking in other places, like agriculture and healthcare, I mean, these are enormous uses of data in those organizations. Incredible. Government, obviously, in so many different ways, government has always collected a lot of data. Now they're finding that it's not just about collecting it, but getting insights and making policy decisions based on it. So it's hard to point to any industry that isn't. If I were to pick one, I would say one that I haven't even mentioned yet, and that's financial services.
Okay.
Because financial services is definitely a consumer touching person, human touching type of industry, right? And again, driven by data. It's all about the numbers. I mean, hello, finances has always been about the numbers, right? I mean, you could say that agriculture wasn't always about the numbers, though of course it was. But well, of course it was. But I mean, I'm just saying that. But finances it's the whole industry is numbers, right? And so the use of data to build products and services and that banking and finance is amazing. And for another reason, not just because the data is there, is because that industry, more than any of the ones I just mentioned, is being extremely disrupted in the world today with decentralized finance, all kinds of fintech startups. I mean, there's a tremendous upheaval in the financial services world. And so if I were to pick one where there's tremendous revolution and evolution with data and eventually total disruption and transformation, perhaps, that's the finance industry.
Okay, that actually makes a lot of sense, that the finance industry actually benefits and leverages that a lot. And I know that leads me to one of your other specializations, which is data literacy. We're curious to understand how you think of data literacy. What does it mean to you? And in today's world, are there specific tools, specific initiatives, specific software framework that is making that data literacy possible seamlessly?
Now, that's an interesting thing to talk about now, because for the longest time, I've been a very big proponent of data literacy in organizations. And then just in the last year, or even few months, I've sort of graduated, so to speak, to data fluency. And by that, I mean, data literacy is such a foundational thing. It's absolutely essential. Okay, so the more it becomes part of an organization, the more invisible it becomes, right? We don't talk about people need to know how to communicate, right? Communication is just something you do to succeed in life, right? I mean, if you're not a good communicator, you're probably not going to get the job anyway. But you don't see that discussed quite so much. And so it just becomes part of what you expect out of everyone. So data literacy is not diminished in importance. It's become more democratized. That is, everyone should be able to see patterns in data, understand what, that there's an insight there. Now, what do I mean by patterns? Let me just back up a second. I've actually done exercises with the general public to teach them data literacy. And I start with toys like Legos. If you're familiar with Legos, they're little colored blocks and you build things with them, right? And so I just I give them a bag of Legos and have them sort it. They can sort it by color, by shape, by size, and have them describe why did they choose the way they did. Okay, so data literacy is about first recognizing that there are features in data. That's one aspect of data, that there's some feature there. There's some insight that you can get, and you can see a pattern, whether it's a correlation or a cluster or an outlier. So frequently, when I gave them those bag of Legos, I always had one that was an outlier, right? So there would be red, greens, and oranges in there. There'd be one yellow or something like that. And so I would do these little exercises with groups of people. So the groups of 2 or 3 or 4 in this big room, and I would just wait to see if any group could identify, oh, we have an outlier. So that's data literacy, is being able to recognize patterns and insights from data and understand, sorting, clustering, correlations, outliers, that kind of thing. But then data fluency comes to the tools you're talking about, where people now said, okay, now I can actually work with data. I can actually produce something from data. And maybe the production isn't like a system, but you could produce maybe a dashboard or some kind of graph, or you can produce something that's going to be important for a decision maker or some aspect of the organization to get, to see the insight you saw and communicate it in a way that brings that extra value. And so those tools that help people to build dashboards, build visualizations, to explore data. So for example, if I can do cluster analysis, maybe I want to extend it to just beyond the two. Let's just say I see 2 groups of things in my data. You can extend that and say, well, are there actually 3 groups or 4 groups or some subgroups? And if you start learning even simple tools that know how to do that clustering analysis. And I've actually taught this to high school students who had no idea any of this stuff in advance. And they learn very quickly about these tools that allow you to basically measure the effectiveness of clustering. All right, so I'm getting very specific here, but this was amazing. This high school student actually solved a problem. He was like a 17-year-old high school student. He actually was working with a NASA research scientist. He was a summer intern when I was at NASA, and he solved a problem using clustering analysis that the NASA chief scientist had been working 25 years to try to solve. All right, by analyzing the clustering of the data properties of solar wind impacts on the Earth, like the northern lights, the atmospheric disruptions that occur, those are all induced by something that started on the sun many days before or hours before. There's some activity on the sun, burst out a bunch of high energy particles, impacted the Earth several hours later. He was able to do an analysis to find all the different states of the sun-Earth system and found the one that identified the best predictor for when this impact would happen on Earth, which affects the power grid, affects our satellites, affects all kinds of things. So putting it in people's hands is to say, well, can you dig deeper into the data besides the fact that you see that there's a group here or a cluster here or an outlier here? Then you get to, then that's where the development tools really become in handy for the data fluent workforce. The data fluent now is actually not just able to see and understand and talk about data, but actually do something with it.
Okay, and that's interesting because you mentioned the one of the primary deliverables of data literacy. As part of that is just a business context, communicating what the data is trying to say, and in today's world, right, of data science, who, according to you, is the data storyteller? Is that the data scientist, or is that the business intelligence developer? Is that the product manager? Who plays that role? Who's supposed to play that role?
Well, I'd like to think all of those people play the role, right? Okay. I mean, this goes back to my story about being an astrophysicist. And I mean, one of my first big sort of breakout moments, so to speak, is I was the keynote speaker at a medical statistics conference, right? And so I said, my first line when I started my keynote talk was, I said, "You're probably wondering why this astrophysicist is standing in front of you," because it was a medical statistics conference, right? And I've been at marketing analytics conferences, and I start by talking exactly the same way. So I think the data storyteller is that person that is the glue that connects these different groups that you've talked about: the data science group, the engineering group, the business analysts, the product managers. All those people need to be able to communicate with each other through data. Because again, data is the fuel. Data is the innovator. So I mean, what do you call that? Basically, the stimulant or the accelerant of innovation in the business. So no one should be excluded from being able to communicate and talk about data. And so I tell people it's really about, explaining in very human terms. And sometimes I call that talking the walk. I mean, some people wonder what I mean by that. Okay, so let me just back up a second here. Back in the early days of the big data revolution, maybe 10 years ago, and it really just kicked off big time. A lot of people were talking the talk. And what I mean by that is they could use the buzzwords in a sentence, right? We have big data. Oh, we have lots of data. We have tons of data. We have more data than our but, we're doing AI now. We talk about AI now. We're doing AI. It's everyone's talking the talk. Yeah. Then you have people who are the software developers and the hardcore data scientists and engineers, and those product managers who are actually building things, right? So they're what I call those people that are walking the talk. Right, they're actually able to do the thing, not just talk about the thing. But the data storyteller is being able to talk the walk. That is, they can explain the hard stuff that the engineer is doing, that the data science team is doing, that the product manager is developing, that the software developer is building and deploying. They can talk and explain that to other people. So across an organization, across the silos of business, across the different units of the business. So everyone needs to have that some aspect of data storytelling as part of their aptitude. It's an aptitude, just like communication, lifelong learning, curiosity, critical thinking. Those are aptitudes that you want every employee to have. So some will do that more than others, but nevertheless, I think everyone needs to be able to communicate the hard things they're doing to people outside of their group. And that's the data storyteller.
Okay. So in that context, does that actually play a key role in how business drives value from these data science models? Because any conversation on machine learning is almost always accompanied with models being built, but never finding their way into deployment and production and eventual business value. Are there some case studies or scenarios or companies or industries where they do this really well, whether the model to deployment ratio and model to business benefit is much better? And is that better because of storytelling or other ingredients in that?
That's a good question. I don't know too many insights into too many companies other than just what I see from the outside.
Yeah.
And certainly a lot of, going back to what I said a little bit earlier, but a lot of consumer facing organizations have really mastered this. I mean, they certainly in the retail world, I'm not sure if this is true across all retail and consumer packaged goods organizations, but they're very, very low margin businesses, right? So certainly the food industry is a very low margin, which basically means the company is struggling very hard to make any kind of a really good profit because it's of the type of industry they're in. And so the more insights they can get from their data to deliver what the customer wants when the customer wants it at the moment that the customer needs it, so to speak, it's better for them. And so they are doing a lot more of this communication around data, understanding the data. I was giving a talk on some uses of AI for example, in a retail marketing storytelling session I was in. And I was just sort of giving sort of my perspective. And there was a guy in the audience who was he wasn't even a speaker. He was just a participant. He spoke up. He said, well, hey, I run a lot of retail stores. He said, I'm a business owner. I run a lot of retail stores. And we have cameras in our stores. And we look in the cameras, not just like to say who's in the store, but what are they looking at? What are their eyes looking at? Where is their attention focused? What do they first go to? Where do they stop and linger? Look, he said, that's data. All right. It may not be in a table form, but knowing that people are interested in this or interested in that, or even one case, they set up these displays in the store. Like as you walk directly into the store, there was a display. There was one on the left and one on the right. So they tested these locations in his different stores, sort of traditional A/B testing. And he found that most customers, as they entered the store, in this particular store, I don't know what the layout was, but they would all more than 50% of the people would go to the left as they entered the store.
Wow.
Why? I don't know. What kind of psychological thing there? I have no idea.
Uh-huh.
But you figure if
Very
it was
interesting.
if it was equal probability, 33, 33, 33, plus minus,
Yeah.
but to have more than half go one direction. So he learned from that people just by watching the foot traffic. Again, it's not necessarily data like you have in a database. He could just see that people were turning that way. So put the display over there, because that's where the majority of people go. So I think in these types of industries, you're going to find more and more people doing those things. And just like I was just telling you this story about people walking in the store and their eyes are fixed on a product, that's data storytelling, right?
Right.
I'm not data storytelling. I didn't tell you any numbers.
Yeah.
I didn't tell you about decision trees or random forest or neural networks. I was telling you in very human terms what was going on, and that's data storytelling. And so this guy's and who was an audience member during my talk, he actually called me out, and I'm glad he did. He said, "Hey, I'm already doing this stuff. I'm just not doing it with deep learning and computer vision and neural networks. I'm doing it with my own eyes. I see where the people are going and what they're doing and what they're interested in, and that drives his decision making in his business." And so he can communicate that, since he's the overall owner of this big store franchise chain. He can communicate that to his individual store owners. Said, "Hey, set the display here. Or customers this season are interested in this product. Make sure that's highly visible when they come in," and so forth and so on. So he can now communicate that in a very human way, which we call, again, data storytelling, without saying, "Hey, my neural network said you should do X, Y, Z." And people will probably take that and say, "Ah."
Right.
I mean, that's how a lot of these situations don't actually get off the shelf. Like you said, there's a lot of development that never gets deployed. And if it does get deployed, it doesn't get used. And a lot of it is because it's not communicated well. What's the value?
Yeah.
And I think once you communicate the value, two things happen. First is you start building advocacy. That is, other people in your business start seeing, "Hey, this is producing good stuff. I should be involved with this, right? I want to be involved with the thing that's helping my company succeed, because that looks good for me too, right?" So that's one thing that happens. But the other thing, it's called the flywheel effect. That once something gets moving, the momentum gets going. I mean, I'll use my background in physics a little bit here. Once you get that momentum going, it's Newton's third law. It's hard to stop it, right? Once things are in motion, they stay in motion unless there's some force that impedes it, right? So let's get that flywheel going, get the advocacy going, so that people across the organization see it. And the best way they're going to see it is if it's communicated well.
Got it. Very, very insightful. Thanks for that. And just my final question, Dr. Kirk, is that I know mentorship and career development and learning and teaching is very dear to you. So today, when you look at the space of skill development and mentorship and training out there, what white space, if any, do you see? And if you were to start a business in that space today, how would you go about doing that from first principles?
Are you asking specifically in the data industry or just the whole world of mentoring?
I would say specifically in the data industry, software development, that industry, yeah. Software, data,
yeah. Well, one of my tricks when I was teaching at the university, and I still do that now in my public lectures, is what I call playing with people's minds, right? Say things that get them to stop and think. What did you just say? Right? Get them thinking. And I think too much. I'm not blaming anybody. I was at a university. I get it. But a lot of times it's just, you just tell instruction and training is just telling people things, as opposed to letting them just sort of like get that question in their head. Why is that? The reason I became an astronomer, an astrophysicist, when I was 9 years old, a relative of mine gave me this picture book of astronomy stuff, right? Nothing very technical, just beautiful pictures of stuff in space. And I just wanted to know, how does that work? Why is that? What made it do that? And so have people say things to people and start with sort of open-ended open-ended problems, like this student I told you about who was able to predict the solar wind impact on the Earth.
Yeah.
He's looking at the data, said, well, what if there's like these different sub states of the system, right? Not every solar flare ends up with an impact on Earth. So what are the ones that are specific? And so then he started thinking about clustering analysis and started thinking about asking questions like, what if I cluster the data this way or that way? And so I didn't tell him to do all of that. I didn't tell him anything. I just gave him this little lecture on clustering analysis. And 2 weeks later, this chief scientist from NASA calls me up and asked me to come to his office because he had to tell me something. And And I was a program manager. So when I get that call from the NASA chief scientist, I have to talk to you about something in my office. It usually wasn't a good thing, right? usually someone on my project he wanted to talk to me about, but it was all good. He said, "Wow, what did you tell these people?" I was like, "What?" I said, "This young man just solved the problem I've been working on 25 years." And so open up people's minds to allow curiosity, allow inquisitiveness, allow them to sort of deviate from where you think the lesson should go. Now that's a general mentoring training answer. Now I know I'm running on here, but I want to just also give a very specific data related sort of mentoring training suggestion, which I think might be missed. I haven't sat through a lot of data boot camps, so I don't know if this is actually missed, but I spend a lot more time in data profiling. That data profiling I call getting to know your data up close and personal, or like I like to say, it's having your first date with your data, right? So that's how I was as a scientist. Even when I got out of graduate school as a PhD, I worked for the Hubble Space Telescope, and they put me in charge of this database. And I was the youngest guy there, and I was doing very simple, trivial things with the database. But I started discovering all these kind of interesting things about the data. For example, data quality problems. If nothing else, data scientists, data analysts, data anybody needs to identify when there's a data quality problem, right? That if there's something wrong with the data. And so I was able to, just by getting up close and personal with the data, doing all kinds of queries and plots, and just sort of min-max ranges, just even simple things like that. What it does is gives you a fluency in data. But at the same time, it starts triggering, well, what can I learn from this pattern? What can I, so instead of me just telling people, hey, go do a correlation or a clustering or outlier analysis, they're already doing it. They've already been inspired to do it just by hanging out with their data. Okay. Right. And so I think there needs to be more time for people just to hang out with the data. And then you're not telling them what to do. You're standing back and watching them do amazing things. And that's what I saw with my students. I had students in my introductory class. My intro class at the university was a science introduction class. Mm-hmm. So every student in the university, no matter what field of study they're in, needed at least one science course to graduate from the university. So even if they weren't science at all, they could have been art, music, sports, they could be business, they could be anything. Mm-hmm. But every student needed at least one science class, at least one math class, and things like that. And so a lot of students who needed that science class came to my class because they said, oh, physics is too hard, biology, chemistry, they didn't want those things. So they came to my class and they said, oh, I hate math, I hate science, but I need this class. And so I just allowed them just to play with things. And I showed them how to do some of the things they wanted to do, like find the patterns. And I showed them some techniques. And at the end of doing this stuff, I told them, hey, guess what? You just learned calculus. Because I sort of led them into learning calculus without ever calling it calculus. I never called it calculus. I just showed them how they can use that technique, that mathematics, to do the things they wanted to do with the data that I was showing them. And they were just stunned because these are students who basically hated math, right? And all of a sudden, I learned calculus. What? And so don't set out with like a decision step that like, okay, you will now learn calculus. Okay. Decide you're going to learn it because that's what you're going to do now. No, show them something that fits more natural into the human inquisitive curiosity, critical thinking things that we were all born with. And that's my lesson. We're all born with curiosity. We're all born with asking questions. If you ever raised a child or seen a child, why, Daddy? Why? I mean, right. And they're testing everything. They're putting everything in their mouth, even though you tell them not to do it. So we're natural born scientists. So let that just happen. No matter who the people are, just let it happen, and you'll see amazing things. And I did in my class. I mean, it brought tears to my eyes. Just the success I had there. I wasn't even like intentionally trying to do that. I just wanted to teach people something and tried to keep the fear factor out of the. So I didn't call it calculus because I didn't want to have that fear to go up and say, "Oh, I'm not going to learn this. I can't learn this." I just want to show them some stuff. And at the end of the term, they were just amazed at what they had learned, and thanked me quite a bit. And even one student, he just said it was the best. He said it wasn't just only the best science class he ever had. He said it was the best class he had ever had.
Wow!
And all of a sudden he said, tell me more math and science courses I can take. And this is the guy who, the first day of the class, I remember him. First day of the class, he says, I hate math and science. I hope you don't have any math in this course. And I said to him, I said, there will be math, but I'll teach you the math you need to know. So don't worry about it.
Okay. That's a fantastic story. I wish I had the opportunity to take that class when you were teaching that.
Well, it was pretty simple stuff, but it inspired people to learn more. And that's my number one lesson. People come to my classes, they say, oh, this is very elementary data science, very elementary machine learning. But what I get out of that is I've had several PhD students who went all the way to PhD. I mean, they were inspired to go all the way, starting with very sort of simple things that that inspired them with. And that's how I feel successful, is that I can inspire people to go on. I'm not going to teach them everything they need in life. I'm going to teach them that they can take that first step and not be afraid. And then it's the flywheel effect. Once they get moving in that direction, they want to keep on going.
Yeah, that's amazing. That's a wonderful way to end this conversation. The whole idea of inciting curiosity, let the data speak to you, and just lead them to a place where you kind of inspire their future flywheel. So yeah,
I love it. Future flywheel. I love it.
Future flywheel, yeah. Well, thank you so much, Dr. Kirk. This has been super helpful, enlightening. I'm sure our community took away tons from it. Thanks a lot.
It's been great. Thanks.